Hello class and welcome to another math lesson. Today we are on section 5.5 and this is actually 5.5 day 2. On day 1 what we talked about was simplifying radicals, which is what we're talking about again today. However, the difference between yesterday's lesson and today's lesson is yesterday we did simplifying radicals where we didn't have any variables. They were all just numerical values. They were all numbers. Today's lesson, we're going to throw variables in there as well. So I just want to start off just a very short activity to get you thinking about the relationship between our integer numbers and our variables. One thing that I want you to think about is when we say 7 squared, we say it's 7 multiplied by 7, and that gives you 49. So that's going one way. Now the other way is saying the square root of 49 is we're kind of saying what times what equals 49, and obviously that number is 7. So for this way, we're in our heads, we're thinking 7 times 7 equals 49, so the square root of 49 is what times what? It is 7 times 7. So the square root of 49 equals 7. So that's going to be one thing that kind of gets you going with this lesson today. I'm going to refer back to this example. One other thing that I want to go over before we get into our lesson is just a couple terms so that we're all speaking the same language. If I say the square root of, we'll just stick with our 7, so the square root of 49. Okay? Now it's always written like this. What it happens is right here there's an understood 2 because it's the square root of 49. It's possible to have the third root of 49 or the fourth root of 49, whatever the case might be. You're always going to see the cubed root with a 3. You're always going to see the fourth root with a 4. You're always going to see the fifth root with a 5. However, when we say the square root, you will very seldom see a 2 right there, even though it is understood that a 2 is indeed in this spot. Okay, so that square root, it's not written as a 2 right there, but it's understood that it is there. What I want you to know with this is that this number right here, that is called the index. Okay, there's a special term for that. It is called the index. So the same thing with this 3, this is the index, the 4 is the index. That number in the top left there, that is called our index. All right, this radical, that's what it's called. It's called the radical sign, or it's called a radical. The number underneath the radical, or it could be a letter underneath the radical, that is called the radicand. That is called the radicand. And then one more thing, if it was like 49, to the 5th power or something like that, this 5, no surprises to anyone, this 5 is called the exponent. So there's 4 terms that I need you to know. The biggest one, I suppose, is this one. This is one that you haven't been introduced to before. That number in the top left, that is called the index. So we have the index, we have the index, we have the radical, the radicand, and then the exponent. Okay? So those numbers I want you to know. All right, simplifying radicals with variables. So now with this very first one, I started this lesson with an introduction as saying the square root of 49, in a way we're asking ourselves mentally, what times what equals 49? And that number is obviously 7. So going with that same philosophy, I ask you with this one, the square root of x to the 12th. What times what gives you x to the 12th? What times what gives you x to the 12th? Let's just think about this for a second. If we say x cubed times x cubed, what does that give you? Well, with common bases, we add our exponents and we get x to the 6th. So if we say x to the 4th times x to the 4th, what does that give us? Well, 4 plus 4 equals x to the 8th. I'm sure that you're understanding now where I'm going with this. What times what is x to the 12th? Quite clearly, that is x to the 6th multiplied by x to the 6th. That number gives you x to the 12th. So x raised to the 6th that number squared, which is the same thing as x to the 6th times x to the 6th, is x to the 12th. So that's going from, that's kind of like saying this whole thing. 7 times 7 equals 49. So the square root of 49 is 7. In the same way, x to the 6th times x to the 6th is x to the 12th. So the square root of x to the 12th is that x to the 6th. This is our answer for the first one. It is x to the 6th. And one way you can kind of look at this, when it's the square root, which today all we're dealing with is the square root, if there's an understood 2 right there, all you have to do is divide the exponent by the index, which the index is always 2. So 12 divided by 2 is x to the 6th. And you could really do that with every single one of these. The problems get slightly more difficult as we go, but for the most part, being that today's lesson is all on the square roots, we can always divide by that 2. Going on to the next one. First of all, just clarifying, our answer here is x to the 6th, because the square root of x to the 12th is x raised to the 6th power. On this one, the square root of 36x to the 10th. Well, let's take our coefficient, and you guys all know what the square root of 36 is. It is 6. And what's the square root of x to the 10th? What times what gives x to the 10th? X to the 5th multiplied by x to the 5th gives x to the 10th. So the square root of 36x to the 10th is 6x to the 5th. And hopefully this makes sense too, because if you were to take 6x to the 5th and you were to square it, meaning multiplying it by itself, what is 6 times 6? 36. What's x to the 5th times x to the 5th? X to the 10th. So if you were to square your answer, you should get right back to your radicand again, which indeed we do. So hopefully that makes sense. Our answer is 6x to the 5th. Now this isn't our complete answer yet, because notice what this rule says. If an even index, which our index is always going to be even in this lesson because it's always a 2. We can have a 4th root or a 6th root or an 8th root. Those are all even indexes. If our index is like the 3rd root or the 5th root or the 7th root, this rule doesn't apply. We don't even have to pay any attention to it. However, if the index is even, which in this lesson, every time the index is even, and it results, meaning the answer is an odd exponent. Our exponent is 5, is it not? Which is odd. If that is the case, you need an absolute value sign. So our answer is 6 times the absolute value of x to the 5th. In class, I expect you to have that absolute value sign in there. The reason for that is because we only know how to take the square root of even numbers, such as like the square root of a negative 49. Remember how we said that is a non-real answer? We don't know how to do that yet. In class, what would happen if x was a negative number, such as like a negative 32? Sorry. Such as a negative 2. Well, what's a negative 2 raised to the 5th power? A negative 2 raised to the 5th, that number is a negative 32. So a negative 2 raised to the 5th is a negative 32. In class, we can't take the square root of a negative number. So that's why whenever you see an odd exponent, that result, with an even index, you need this absolute value sign in there. So we'll be getting more practice with that today, but make sure you always pay attention. If you get an odd answer, always look at your index. If your index is even, you have to have an absolute value sign. If your result is an even exponent, you don't need that absolute value sign. This rule is now irrelevant. In the same way, if you have an odd index, once again, don't even worry about the absolute value signs. You don't need them. It's only in this case. Even index results in an odd exponent. All right, moving on to number 3. So the square root of 4 is 2, and the square root of x to the 14th is 14 divided by 2 is 7, or x to the 7th times x to the 7th is x to the 14th. Once again, you have an odd index, or you have an even index with an odd exponent. That's 7 right there. So you need absolute value signs around that. 2, absolute value, x to the 7th. Number 4. This is one that's going to tie in yesterday's lesson with today's lesson. You have the square root of 50, which you cannot break that down. 50, rather, is not a perfect square. However, it is 2 times 25. So 2 times 25 is 50, and then you have x to the 4th. You can't take the square root of 2, so this has to stay underneath the radical. You can take the square root of 25. It comes outside the radical as a 5. And you can take the square root of x to the 4th. It is x squared. And then you still have the square root of 2 underneath your radical. Your result is an even exponent, so you don't have to worry about this rule. So this is your answer. 5x squared, square root 2. Number 5, breaking this down again, 27 is the same thing as 9 multiplied by 3. You still have your x to the 12th, y to the 6th. It's the square root of all this, so the square root of 9 is 3. This 3 has to stay underneath the radical. X to the 12th can come out as x to the 6th. Y to the 6th can come out as a y cubed. And then you still have this 3 underneath your radicals. So times the square root of 3. This y variable is raised to the 3rd power, so it has an exponent of 3, which is odd. If you have an odd exponent with an even index, you need that absolute value sign. So for number 5, the correct answer, 3x to the 6th, absolute value y cubed, square root 3. I want to let you know, class, that accelerated math doesn't have this absolute value sign in their answers. They should to be mathematically correct, but they do not. So just be aware of that when you're doing your Excel math homework. But any worksheet or any test that you do for me, I expect you to have this absolute value sign in there. Number 6, this one gets a little bit trickier. Notice how when we had like the square root of 50, we can't take the square root of 50 evenly. We get a long decimal answer. So when that's the case, we break it down into 25 multiplied by 2. Right? Now listen very closely. I cannot take the square root of x to the 5th and get a nice clean-cut answer. Okay, I would get like a long decimal answer such as the square root of 50. However, I can simplify x to the 5th. What I mean by that is I can break it up into 2 different factors in the same way I broke 50 up into 2 different factors. And here's how you do it. X to the 5th, isn't that the same thing as x to the 4th times x to the 1st? In the same way, isn't 25 times 2 50? Same thing as x to the 4th times x to the 1st is x to the 5th. The reason why I do that here in this case is because I can't take the square root of an odd number right here. Because my index is 2, any exponent I can just divide by 2, but the ones that come out nice and even are the even numbers. X to the 14th, the square root of that is x to the 7th. X to the 20th, the square root of that is x to the 10th. However, if I get an odd number here, 5 divided by 2, that 2.5, that doesn't translate very well. So what we're going to do is we're going to break it up into the highest even number that we can, which this one is x to the 4th. And x to the 4th times x to the 1st is x to the 5th. So now I broke this up into 36 times x to the 4th times x to the 1st. And now I can take the square root of 36, it is 6. I can take the square root of x to the 4th, it is x squared. I cannot take the square root of x to the 1st. So in the same way, I cannot take the square root of 2, I leave it underneath the radical. Because I cannot take the square root of x to the 1st, I just leave it underneath the radical. So my answer is 6x squared times the square root of x. So kind of think to yourself in the way that you broke down these numbers. you kind of do these letters the same way. You break these numbers into something that you can take the square root of. You break up the letters into stuff that you can take the square root of. You can take the square root of x to the fourth. Whatever you cannot take the square root of, you leave it underneath the radical. So number 7. Why don't you guys try this one on your own, pause the video, and then check your answers with me after you're done. The square root of 49z cubed. I can't take the square root of 49z cubed. I cannot take the square root of z cubed. However, I can z squared multiplied by a z. Because z squared times z to the first, with common bases, you add their exponents to get z cubed. So hopefully all of you can see that I didn't change anything to get from here to here. Nothing changed, it just looks a little bit different. So now, I'm going to take the square root of anything that I can take the square root of, such as 49. I can take the square root of that to give 7. Z squared, I can take the square root of that. It's 2 divided by 2, which is 1, so it's z to the first power. Or if you want to think of it this way, what times what is z squared? Z times z is z squared. So actually you don't even need this 1 in here. It's understood. 7z, and then this is left underneath your radical. Square root of z. Now class, there is an understood 1 right here. When that's the case, this is an odd exponent, and we had an even index, so I need absolute value signs right there. 7 times the absolute value of z times the square root of z. I hope that makes sense to you, and I hope that makes sense to you. Be sure to let me know if you have any questions on that. I'm now going to have a new lesson going on 7, 8, 9, and 10 on our notes for today. That's going to be adding and subtracting radicals with variables in them.